so let's have a look at, let's say just the first few of these. Okay, so let's just walk through number 1 for right now. If I want to predict the products of a chemical reaction, what's step number 1? Identify the reaction type. Okay, in this reaction, my reactants are a hydrocarbon, okay, so a carbon-hydrogen containing compound, and oxygen. What's my only reaction type that starts that way?
Combustion.
Combustion. Okay, I know that sometimes people get confused with single replacement because it's a compound and an element, but remember, it's not an ionic compound, and replacement reactions are always ionic compounds. This is not ionic. Okay, all right, so we've identified it as a combustion reaction, step 1. All right, step 2, I got to figure out what my products are. And for a combustion reaction, that's easy because it's always the same 2 products. What are they? Right, CO2 and water. So I'm simply going to write CO2 plus H2O. And in a combustion reaction, I want to write water as H2O. In a replacement reaction, I probably want to write it as HOH because it's easier to track where everything goes. All right, so now I've got that done. What's my next step? Balance, yeah. I mean, I can check for special elements and do the swaps and drops, except I don't need to do those for this reaction because I don't have any special elements, and I don't have any ionic compounds, so those steps are kind of already done for me. So now I need to balance. Combustion reactions have special balancing rules. Do I need to apply the rule of 2? Yes, I have an even number of carbons, so I'm going to start with a 2. Okay, and then I'm going to balance in alphabetical order. How many carbons are there?
4.
4. 2 times 2 is 4. How many hydrogens are there?
12.
12. Okay, what times 2 will give me 12?
6.
Okay, now I can look at my oxygens. So here in the water, I've got 6 oxygens, plus another 8 here in my carbon dioxide for a total of 14 oxygens. What times 2 will give me 14?
7.
Done. Okay? So as long as we know the steps, predicting the products of a chemical reaction is pretty formulaic. It's basically just follow the steps, and you can't go wrong. Okay, let's try this next one. So on number 2, I have sodium nitride reacting with magnesium. What kind of reaction starts with an ionic compound and an element? Single replacement. Okay, in a single replacement reaction, I have to swap the things that are alike. So my single element is a metal, which means it's going to swap out with the metal in the ionic compound, which will leave sodium by itself and magnesium with nitrogen. Okay, single replacement reactions have the most things to check for after I have figured out who's who in the soup. Okay, who goes with who. All right, I need to check for special elements. Do I have any special elements? No. Sodium is a metal. There aren't any metals that need little numbers on them. Okay, and then I need to drop and swap. Right, so for this compound here, nitrogen is a -3, magnesium is a +2, so when I drop and swap, I'm going to get Mg3 and 2. Okay, so what should I balance first? Okay, our gut reaction is go with the biggest number. Coder, you told us always start with the biggest number. The problem is if I do that, I'm going to get to nitrogen and not be able to balance it. And then I'm going to have to start over. Here's why. Okay, if I put a 3 over here, okay, like this, that's great. And then I look here, oh, there's 3 magnesiums. I put a 3 here. Oh, there's 2 nitrogens. Uh-oh. I got to put a 2 in front of this. That's going to change the sodium. It's going to change the magnesium. So, okay, this is one of those rare occurrences where starting with the biggest number doesn't work. It usually happens if nitrogen's involved. Okay, it's just one of those ones that it's a troublemaker. Okay, nitrogen and oxygen are like the 2 troublemakers of the chemistry world. Okay, they make everything difficult. All right, so I'm going to start with nitrogen. There's 2 over here, and okay, there's only 1 here. So I'm going to put a 2 in front of this. That balances my nitrogens. But it gives me how many sodium? 6. Okay, so now I've got 6 sodium. Okay, so sodium's balanced. Now I just need to make my magnesiums work. How many over there? 3. What goes here? Okay, so the 3 was actually okay for the magnesium. Right, just didn't work for the sodium. Okay, anything else I need to do with that one? Okay, did I follow the same steps? Every time. Okay, every time I follow the same steps. Okay, what kind of reaction type has only one reactant? Decomposition. Right, in a decomposition reaction, atoms are going to be separated, okay, according to Dalton's atomic theory. So I'll have magnesium and nitrogen. All right, what do I need to check for?
Special elements.
Special elements. Magnesium's not special. I know that hurts its feelings, but it's not. Okay, and nitrogen is. Comes as a? Okay, so now I've got that set. All right, I've checked for special elements. I don't have any dropping and swapping because there's no ionic compounds. Next is balancing. Okay, nitrogen's already balanced. Now magnesium's balanced, and I'm done. Okay, always the same steps. Okay, if that's seeming like I'm beating you over the head with it, I'm sorry. Okay, I'm not trying to belittle your intelligence. This is just one of those really important skills we have to know, and it really comes from repetition. Okay. All right, I'm going to let you guys try the next 3. Okay, I'm going to give you a few minutes to get ahead of me, and then we'll walk through those. Okay, so for number 4, I've got sodium permanganate reacting with iron 2 sulfide. Okay, what kind of reaction am I looking at? It's a double replacement reaction. They're both ionic compounds. I mean, we only have one reaction type that is 2 compounds. Okay, and it's double replacement. So in a double replacement reaction, the pattern is that the metals are going to switch partners, which means that iron is going to end up with permanganate, okay, and sodium is going to end up with sulfur. Now, I often get asked, does it matter which order my products go in? And the answer is no. I could have written NaS first and FeMnO4 second. That doesn't matter. It doesn't matter which order. As long as it's metal, non-metal, metal, non-metal, everything's good. Okay? Everybody with me there? All right. So, I've just made 2 new ionic compounds. What do I need to do with them? I need to drop and swap them. Now, the first one is with iron, which is multivalent. So I need to figure out, was iron a +2 or a +3 on this side? Okay, so I look at sulfur. Sulfur's a -2, so this iron was a +2. All right, so now I know which one to use in my drop and swap. What if this was a single replacement reaction and iron was by itself? How would I know which charge to use then? Yeah, you can't figure it out, can you? Like, there's no way to figure it out. So what you do is you go with the most common charge, which is the first one listed in the box. Okay, so for iron, that's 3, right? Okay, so if that situation does come up occasionally, that's what you do in that situation. If you have no way to figure it out, you go with the most common. In this case, we did have a way to figure it out, so we figured it out. Okay, but if you don't, that's what you have to do instead. All right, so this is 2+, this is a -1, so I'm going to need brackets around the permanganate, and a 2 outside of the brackets. And then this is a -2, and this is a +1, so I'm going to need a 2 here. I don't have any special elements to look for because my products are both compounds, so that step is taken care of. What do I do next? Balance. Okay. What should I balance first? Yeah, permanganate or sodium, doesn't matter. They go together on the other side anyway. So if I start with permanganate, there's 2 over here. Putting a 2 here balances both my permanganate and my sodium and the whole reaction. Okay, so that was all I had for you to balance. Questions on number 4? Well, let's have a look at number 5. Okay, so number 5 is a situation like we just talked about in the last question. Right? What kind of reaction is it?
Synthesis.
It's a synthesis reaction. Okay, because our reactants are both elements. So they're going to go together to form a single compound, Cu with F. Copper, however, is multivalent, and because it was by itself, I have no way to figure out which charge it had. So I have to go with its most common charge, which is 2. All right. So copper's a 2 plus, fluorine's a -1, CuF2. Okay, there's no special elements to check for here. Now I need to balance. Done. That one was easy. Okay, already balanced for me. All right, and then let's have a look at number 6. So I've got H2SO4, so hydrogen sulfate, reacting with magnesium hydroxide. What kind of reaction? Double replacement. They're both ionic compounds. Okay. In a double replacement reaction, I am going to swap the metals to make my products. Okay, so that means that hydrogen will end up with hydroxide, and magnesium will end up with sulfate. Okay, as I said before, it doesn't matter which order you write the products in, as long as it's metal, non-metal. Okay. All right. Next step. Drop and swap. +1 -1, that one's good. +2 -2, that one's good. All right, I've done all my drops and swaps. There aren't any special elements to look for. Now I need to balance. Okay, so I'm going to start with hydrogen, because there's one hydrogen in the products, but there's 2 over here. So I'm going to put a 2 there. Okay, and again, that's why I write it HOH, right? Because that way I can track where the hydrogens and the hydroxides come from, and I don't get confused with the hydrogens. Okay, so that balances both my hydroxides and my hydrogens, and everything else looks okay. So now that one's done. All right, that making sense? Okay, the only thing that can make these more challenging is if I give you the reactants in word form. Because then you also have to do all these steps for the reactants. You have to drop and swap ionic compounds. You have to check for special elements. It's not harder, there's just more stuff to do if I give you the reaction in word form. Okay, and I might do that some. All right, I can't remember if I had some word ones. I did. Maybe I don't. Okay, let's have you guys finish these ones off. Okay, so for number 7, we've got tetraphosphorus pentaoxide, okay, and it's our only reactant, so that is what type of reaction? Decomposition, okay? So that means it's going to break down into its 2 elements, phosphorus and oxygen. In any decomposition reaction, the most important step is to check for what? Special elements. Both of these are. Phosphorus is always a 4 by itself. Okay, and oxygen is always a 2. Okay, so phosphorus already looks balanced, but the oxygen is obviously not. Okay, so lowest common multiple of 5 and 2 would be 10. Yeah. Okay, so I need to put a 5 in front of the oxygen here, and a 2 in front of the tetraphosphorus pentaoxide on this side, which is going to give me 8 phosphorus, so I just need to put a 2 over there, and now it's balanced. What if when you're balancing, you end up with all numbers that you can reduce? Should you?
Yes.
Yes. Okay? Balancing should always be in its lowest term. So if you have a look, and it sometimes happens with phosphorus and sulfur, sometimes we accidentally go too big, okay? Make sure that you then reduce it down after the fact. Okay, for number 8, I have tin reacting with beryllium nitride. What kind of reaction am I looking at there? Single replacement. I have an element reacting with an ionic compound. Okay, so the pattern goes, I switch the things that are alike. Tin is a metal, so tin is going to swap out the metal, which is beryllium. So beryllium will end up by itself. Tin will end up with nitride. All right, checking for special elements. Don't have any. Beryllium's a metal, so it doesn't need a number. Okay, but I do have a problem when it comes to the drop and swap. Tin is multivalent. It can be a 2 or a 4. Which one is it here? 4 is the most common charge, right? Okay, it's the one that's listed first. Okay, so this is tin 4. Okay, and nitrogen's always a -3, so we got SN3 and 4. Okay, as our properly dropped and swapped compound, and now we have to go back and balance. I got lots of numbers here, but my best bet for balancing would be to balance my nitrogens, which happen to be the biggest number, okay, first. So there's 4 on that side. If I put a 2 here, that'll give me 4 on the reactant side. It will also give me 6 beryllium. So I've got to put a 6 in front of this, and make sure my tin balance. There's 3 over here in the products, a 3 over here in the reactants. We'll fix that. And now it's balanced. Okay. So again, generally picking the biggest number works. There are going to be the odd reaction here or there. Okay, probably 1 out of every 10 or so. Okay, that you'll have to start with something else. Okay, number 9, sodium bromides reacting with lead 4 sulfide. Okay, what kind of reaction am I looking at? Double replacement. So in a double replacement reaction, I swap the metals, so that means that sodium will end up with sulfur, lead will end up with bromine. Now, when I was reading this reaction out, okay, in words, I said this was lead 4. How did I figure that out?
Because sulfur has -2, and there's 2 of them.
And there's 2 of them, right? There's each sulfur is -2. There's 2 sulfurs. That's 4 negative charges. So the lead must be the +4 lead. Okay, bromine's a -1, so we're looking at PbBr4. Okay, and then for sodium and sulfur, this is a -2. That's a +1, so we're looking at Na2S. All right. So we've dropped and swapped, there aren't any special elements to speak of, so now I need to balance the whole reaction. I would say probably starting with bromine is the best idea. Putting a 4 here balances the bromine, but it gives me 4 sodium. A 2 here gives me 4 sodium and 2 sulfur. And there's 2 sulfur over here. 1 lead, 1 lead. We're good. All right, and then we got the last one. Sulfur's reacting with calcium. What kind of reaction?
Synthesis.
Synthesis reaction. So in a synthesis reaction, we're going to put the 2 together. Now, when I write a reaction, synthesis reaction this way, this is what about 1/3 of people do because they don't think about it. What's wrong with that?
The metal.
Metal has to go first. It's an ionic compound. I don't have a lot of tricks, okay? I really don't have a lot of tricks in the bag. That's one of them, and I use it all the time. Okay, so expect it on a quiz or a unit exam or something like that. Because like I say, I don't have a lot of tricks, but that's a good way for me to test whether you remember that in an ionic compound, metals are always written first. Okay, so once I've written that out, now I can check my drop and swap. -2 +2, good the way it's written, okay? And we just want to balance this thing now. So we've got 8 sulfur over here, that's my biggest number, my only number, okay? So I put an 8 over here to balance the sulfur. I'll need an 8 in front of the calcium to make the rest. Okay, how are we feeling about predicting the products of a chemical reaction? Yeah, starting to get it? Okay, are you starting to see why I kind of harped so hard on being able to drop and swap and write names and all that? Because, I mean, you've got to be able to do that here, right?
I just have like a question of clarification, but
Okay.
like for reducing and stuff, like
Mhm.
say if it was like 2 and 4 on one side, but it wasn't like even on the other side, you couldn't reduce it, right?
No, it has to be the whole reaction can be reduced. So if I had 2, 4, 6, 8, oh yeah, I can reduce all of that now. Yeah, but if I have 2, 3, 6, 8, nope, it's already low as it can go. All right, so we're feeling better about that. Figure we can get that. Were there questions in regards to the lab? Does anyone have questions in regards to the lab? Okay, so I want to remind you of a couple of things when you're putting your lab report together. Okay, first thing is remember that there's 3 recordings, 3 videos in that assignment, okay? One is me going over the pre-lab, that's the longest one, but you can always, scroll through it to the parts you need. But not a bad idea to listen to it while you're putting your lab report together so you get all my hints on the variables and the hypothesis and all of that, okay? There's the observations video. If you weren't confident in all of your observations, it's not very long, okay? Not a bad idea to have a quick look at it, okay, for that. And then obviously there's a short video about the analysis and the conclusion, but I will remind you, in the analysis, question number 1, I need the reactions written out in both formula form, like this, and also in words, okay? So if I'm writing out this reaction here, number 10, in words, it would be sulfur plus calcium, calcium sulfide, okay? So I want to see each form of 1, 2, 3, 6, and 7, okay? Remember, you do not have to do anything with reactions 4 and 5, okay? Remember that question number 2 in the analysis is asking you in reaction number 3 and in reaction number 6, there were precipitates formed, okay? All I'm asking you to do is look at your products and figure out what the precipitate is. So if I was looking at, let's say, number 9 here, okay? One of my products is sodium sulfide, one of my products is lead bromide, okay, lead 4 bromide. So I would go to my solubility chart and go, okay, when I have sulfur with sodium, that's soluble, okay, that's not the precipitate, that means this is, okay? Double check, yes, bromine's not soluble with lead, okay, there's my precipitate. Okay, that's all you have to do is write lead 4 bromide was the precipitate in reaction number 3. Okay, it's not, obviously, it just wasn't in there, but okay, you get the idea. Okay, that's what I'm looking for question number 2. Right. So as I said, on Monday, you're going to get a 30 reaction assignment. It's split up into groups of 10. Okay, the first 10 reactions are going to be the full reaction will be written out in formula form. It'll be fill in the blank to balance and written out in words below. Okay, so for the first 10, you're writing the reaction out in words and filling in the blanks to balance. Okay, the second set of 10 reactions is a full reaction, reactants and products, written in words. You'll have to write it out in formula form and balance and identify the type. Okay, so each one is out of 3 marks. Okay, so in the first set of 10, you get 1 mark for balancing, you get 1 mark for writing the reactants in words properly, 1 mark for writing the products in words properly. Okay, so 3 marks. For the second set of 10, you get 1 mark for the reaction written out correctly, 1 mark for balancing the reaction correctly, 1 mark for the reaction type. Okay, now that's the hardest set of 10 is the second set of 10, because if you mess up one part of the reaction, you'll lose the mark for the reaction, and because you don't have the reaction right, you won't balance it correctly either. Okay, so it's a double whammy in the second set of 10. Okay, one mistake in the reaction will result in the loss of 2 marks. Okay, so you have to be really careful on that set of 10. The last set of 10, I give you exactly what I gave you here. Okay, I give you reactants in formula form. You have to predict the product. So you get 1 mark for each product and 1 mark for the reaction being balanced correctly. Okay? All right. So that one you'll get on Monday. You'll probably get most of it done on Monday. And you might have a little bit to do for homework. It'll probably be due later that week so that I can get it marked and back to you so you can use it to study for your unit exam. Okay. All right. We got 10 minutes left in class. I want you guys to try some of those. Okay? Just because this is the biggest mark thing on your unit exam. Okay? Like on your unit exam, I'm still playing around with it, but I think right now, reactions in general counts for like 2/3 of the test. Okay? So if it was out of 100 marks, it's not. But if it wasn't, 67 of them would be on reactions. So it's in your best interest to know how to do it.
What's like the format of the test? Like, is it like multiple choice, true and false? Or
Yes.
Okay.
No, it's some multiple choice and written response. Okay, there's no true or false.
Okay.
I don't believe in true or false. True! I don't believe in true or false, just because it's, well, 50%
Yeah.
chance, yeah. Unless it's right minus wrong. Then I could be convinced. You guys ever heard of that? This is the most savage way to mark a test. Right minus wrong. So whatever you get,
Oh,
tests
yeah.
out of 100, you get 75 right, you get 50% on the test.
Easy.
Because they take how many right you got and subtract how many wrong you got, and that's your mark. Savage. It's university for you. Okay? So you know what you're better off to do as a strategy on a test like that? Only do the questions you know you can get.
Yeah.
Okay? And make sure that it's half the test. Okay? If you're sure of half of them, done. Don't do any more. If you're just looking to pass.
That's true.
Which, you know, when I was in the higher level chemistry courses was like, yeah, not passed, I'm done. Yeah, walk away now.